can't do that. Hold on.
Alright. Hi, my name is Armin Geoscience. Today I'm going to be talking about ridge push slab pull. In the last century, scientists have found enough research to support the idea of plate tectonics. Plates are large pieces of the upper few hundred meters of earth that move more or less.
The main benefit of knowing when or when activity happens is being able to.
Through this, scientists have discovered that plate tectonics has to do with seafloor spread.
Basically a branch of science.
The big question that scientists can't answer is whether seafloor spreading is caused by something called ridge push.
There's two main approaches.
There's a theory that the mid-ocean ridge pushes rock layers continuously, which causes the rocks to go into the subduction zone, where slab pull, which is the subduction zone, pulls the rocks into it, and therefore causes the expansion. Jennifer Bromley is a scientist from the University of Maine. She did a project, a lab, to prove her point, which is that slab pull is the reason behind
two different ways
seafloor expansion. The item she took a plexiglass tank. She used tapioca pearls to represent the mantle, and flubber to represent continental lithosphere, and putty to represent oceanic plate.
And investigation of the main shock.
She compared it to, for her comparison, she compared it to something called the Maluka Sea. The Maluka Sea is important because it lies within two subduction zones. And the important thing of it is that since it is between two subduction zones, it's expanding and it's thinning out, and it's eventually going to disappear under the sea. The result of Jennifer Bromley's experiment was that slab is what's the subduction zones are what's causing the. It's where the force is. That's where the force is. The subduction zone has the force. How do you?
So, like, what does she think is causing the plate to move?
She thinks that. How do I explain? I know what to say. It's hard to explain it. But she thinks that there's a force on the edges which would represent the subduction zone of the putty. The putty melted down. In her lab, the putty melted down, but it melted down on the edges and stayed up in the middle. So this supports the slab pull theory because the slab pull relies on the edges extending down. All right. So, based on the research that I've done, I believe that slab pull is a theory behind seafloor expansion. The reason I think this is because when I looked for, while I was researching this, I looked for a project to represent ridge push, right? And nobody could recreate a project that shows what ridge push is. Jennifer Bromley did something that shows why slab pull is the answer. Though the thing that is lacking from Jennifer Bromley's experiment is that, first of all, the ocean is on a much bigger scale, and second of all, she has nothing for the mantle to push up off. There's no magma coming out of her mantle.
behind our project is to have those water filtration systems.
This is the graph.
Covering is
Small.
how water.
This is the graph that showed that I was talking about earlier about force. All right. So this black line over here is the putty, and this is where the force was taking place on the edges. And these edges of force represent what slab pull is. The yellow, this is the shear strain rate, and the yellow is where the greatest rate is, while the red is where the lowest rate is. The edges had all of the strain rates.
So how did she use this graph to demonstrate that this was slab pull instead of ridge push?
Because if it was a ridge push, the strain rate would be coming out the middle and then pulling off to the side. But in her research, it showed that everything was coming off the sides and no strain was coming out of the middle.
So then what's your conclusion? What do you think? Which theory is it?
I personally think that she's done enough research to prove that slab pull, and the science is evolving, and what they're doing now is they're going to cut into a rock and see what strain rate it is, see where the strain is coming from. So I believe that it's strain rate, but since scientists don't know yet, I can't give you a definite answer. I personally believe that it's slab pull. Do we have any questions?
So are these just still theories or are they proven?
They are all theories. None of this is proven. And that's why I think this is interesting. Scientists have been studying this for a while now, and none of them know whether, well, some believe that it's ridge push, while others believe it's slab pull, and they can't come to an agreement. There's no scientific explanation of why it's happening. I'm Armin Geoscience, and this was ridge push versus slab pull. I'll be back at you next time.